Hello. Greetings. Welcome. Tonight, I just had a little plan of, I don't have a specific intent in mind here, but it seems like there is a new specification for contact tracing over Bluetooth low energy broadcast devices. So this is, ooh, look at this. We have a big Apple and a big Google right on the same page, right next to each other. Whoa. Uh, this is the contact tracing application. I found out about this was linked from this URL here is privacy preserving contact tracing. Um, so ultimately, at the root of this, the user has a cryptographic key that they're building a daily key with, and then they're generating a rolling key using that daily key. And I don't entirely know, I'm not entirely sure what the protocol is for how everything gets resolved, but the basics of this seem really simple. Um, it seems like there's really those two keys, your like main device key, your main person key, and then your rolling daily key. Um, and so there's a couple different pieces to this. I'm kind of interested in just seeing how much of everything, the like lowest five version of everything that I can like quickly cobble together here. So um, the first kind of step to me is just going to be building a small Node.js application targeting my Linux laptop right there, although I will be working here. Um, and that'll be a super small node program that uses Bluetooth Low Energy to broadcast these packets of personal identifying information over this, saying under this service UUID. So people listening will be able to hear, hey, like this laptop should just be able to be radiating to the world like, hey, I'm here, you've had contact with me, here I am. Part two is starting to build some web applications to listen to that broadcast of identity and gather and hear the fact that people are broadcasting these service identifiers. And so those should be some really simple web applications. And then part three is starting to really dive more into the cryptographic system. So I'm really going to be punting on having actual real data being broadcast from the laptop on this Linux system to start with. It's really just going to be some fake data that comes out. And so part three is really starting to actually build some infrastructure to generate a key and push out a key. So um, let's just write those three steps down real quick. I'll show you this in a second. Part one, we want to. Ooh, orange is not a great color. So number one, broadcast a fake rolling ID via Linux. Part two, Part two, a small web app to listen for contact informations happening on Bluetooth. And so we can run that on a different system and should be able to hear this laptop talking about its contact. And then part three, so all 3 points. Now part three, we've got the using the cryptographic tools to broadcast a real rolling ID. So there's the three different steps here. I think we can dive right in. The first part should be we're going to start with a small Node.js program to be able to do some of this Bluetooth beacon broadcasting. I haven't done a whole lot of ground research to see if the fields has changed much, but I'm assuming that historically I've used the Noble library from NPM, and this has been a pretty good tool for me to be able to send out Bluetooth low energy broadcast items. So we should be able to get started with this relatively quickly. please feel free to say hello in chat if you have anything to say or have any questions. I do have it over on another side of my screen, so you're over here. And then going to bring open a terminal here. We're talking to this laptop over here via SSH. And so just going to start a new project. I don't have any overwhelming goals for what I want out of this project. I think it's an interesting idea to open this toolkit and to start to develop this and make these specifications available and something we can experiment with now. I'm not really sure how much use I expect it to be, but I think it's an interesting piece of technology, and I think it's something that we can just dive right into and start to explore, and that it's something that, if it is going to be a big piece of the technology, I think it has the potential to be an important piece of technology that could help shape and help us steer ourselves. So I think it's important that we work on it and develop it and make this interesting new idea that's supposed to be about a cryptographically privacy-preserving way of kind of being able to be in contact but also disclose things about ourselves when we need to other people who we've been in contact with. I think that's an interesting toolkit to open. So that's kind of why I'm here. That's kind of why I'm doing this. I have a little markdown file. What are they calling it exactly? So it's a decent enough README for now. So where am I? I am okay. Well, the screen is a significant amount behind, but hello. Nope, didn't mean to do that. So we're going to install this Noble library. We already have this service that we're going to start to implement. This is all depending on me being able to actually get any kind of Bluetooth stack running quickly, which let's hope is still a possibility. I've used Noble in the past, but I am not super fresh on it. So I'm just doing an npm install and getting a little bit of feedback from this guy. Node module X. Well, it's not super duper encouraging. Yeah, this looks like it wants it kind of old. This kind of looks like it's not up for my version of Node, which would be unfortunate. 1310. I've used Bleno before too, which is for implementing a I don't know if this is a peripheral. Let's go to the GitHub and see if they have any advice for Node versions anywhere in pull requests. Ooh, that's a lot of issues. Oh my goodness. Oh my goodness. 7 days ago. Yes. Community maintained. Yes. All right. Disaster averted. Abandonware. So I have a little side thing I'm going to do during this. I tend to listen to music in the background usually while I work. So I have Max Cooper's Live at the Barbation, his Yearning for the Infinite show. It's queued up at 1 minute and 15 seconds. And I am... I don't think I'm streaming this audio. I hope I'm not streaming this audio. Am I streaming this audio? I think I have this muted. I feel like I don't actually have this. Okay. Haha. Sorry about that. If you want to listen along, 2 minutes, 10 seconds. This is a wonderful, wonderful background story. Cool. Okay, so we got our version of the maintained version of Noble installed. We're going to head over to the C19T file, and I'm just going to start figuring out what their so this has a discover. This might only actually be for, it was telling me that I wanted Bleno if I was trying to make a peripheral, so I might actually need to be doing something else. Scanning, peripheral. I don't even need to connect to anything. This is really about scanning, but can I advertise anything? Discover included service, event, discover characteristics, read. Yeah, I think I might actually be needing Bleno, which hopefully is also maintained. 2018. Let's just... Okay. Thanks, Razor et al. I appreciate your hard work here. It's important to keep our base tools operational so that we can hack, and I appreciate you doing the good work quite a lot. Did this install? Not okay. Bad. Oof. Did I just try and install Bleno? No, I tried to install abandonware Bleno. Oh, I'm sorry, I'm a little off the screen, aren't I? Again, it's like it just wants a different Node version and has not been updated. I don't see any specific fast mentions. Node 10 or 19 or late. Oh, OS X, Linux 3. Yup. I mean, I think I've got all these guys already installed. This doesn't look like it's any of them. It really looks like a Node thing. it's already installed. Not quite the latest version, but that's installed. Lib Bluetooth dev. Blue dev. Well, that's good. That wasn't installed. So if that's not installed, success is unlikely. I have accidentally told things that they may start updating, which, let's see how this goes. Hey. Any moment now. Apparently, you do not want to do this work inside of a Vim terminal. Today I learned. Yes, dear viewer, it looks as bad for you as it looks for me. Ah, look, a screen that looks like a screen. Thank you. Okay, we're gonna try and reinstall Bleno now, which should be able to hopefully give us the ability to make a Bluetooth device. Still no. There's just too much going on screen before. I'm used to having a little more text area to work with. Wow. Yeah, I mean, this just looks like such a, Node version compatibility issue. Let's... Inconsequential upgrade, but I would like very much to have something to work with. Oh, for one. Yeah, see, it's still way less errors, but still short with me. And it's still v8 value, integer value. It's still like some kind of like simple v8 issue. Is this really? I thought it was like short, but no, it's a lot. Well, do they have any guidance for us in the abandonware/Bleno page? I mean, I'm still running my Bluetooth service. I could stop that, but that's not what's causing this compilation to fail. Node is on my path. Pretty please. it's the version of Node that we had. 10.19 or later. That's confirmed. There's no version specified here. Well. Warning. Deprecated. No candidate. I don't think that was relevant. 051042 3 years ago. A month ago. 051051. This looks so much better, but not having. It does say npm install Bleno, but I think that's just the documentation being out of date, because this is 050, but it's still 2 years old. Yeah, so I still don't trust it. Any current XPC connection. Bluetooth HCI socket. So where's this even trying to install? Bluetooth HCI socket. So some dependency has failed. Okay. Four years ago, which is what Bleno is trying to install, whereas this is maintained a month ago. So that clearly still a failure. How dare you? Why is it depending on something else? It's depending on itself, but its old name, which is quite unfortunate. It's compiling! No! Yes! No, yes! Yes! No, yes! I think it's yelling at us a lot, but I think it worked. I think it didn't fail somehow. Just a lot of deprecated. Still good, still good. Just just deprecated. Don't worry about it. Okay, so I checked out the abandonware copy of Node Bluetooth HCI socket. We're going to look at, and so it is installed into, so it's already the abandonware Bluetooth HCI socket. So now we're going to check out this guy in kind of the similar fashion. Actually, I tend to keep things that aren't quite my own works in this archive subdirectory. We'll relink it so that it's available. So Bleno is what we're going to be using to make a little Bluetooth peripheral. We just got to make this Bleno work. And this is going to be our contact tracing peripheral device, our little, not even a peripheral, it's like even dumber. It's just a Bluetooth low energy broadcast beacon that sends out tiny little packet of data. Okay. It's complaining about libUSB not being available, so we're going to install. It's just going to be libUSB dev. Cool. So this is the, hey now, you should be happy. libUSB 1, I need libUSB 1. Something special for you. Something old, aged. So let's see if this module that we're going to be trying to be using will build now. It's building more. That's a good start. Great. Excellent. Cool. So now I've installed a local working copy of abandonware Bleno. Go back to C19T. Sometimes it's good to trust npm link, but other times and so this is kind of where I had started before. Oh, you know what, though? Cool. Okay, so C19 has this Bleno module, which I just built, hacked into place. I'm not entirely sure if I definitely don't remember how to use it, but we will find out very shortly here. Import it. Advertising. Start advertising. Cool. And does this look like it's going to have what we're looking for? One 28-bit service ID plus two 16-bit service UUIDs. Seven 16-bit service UUID, UID major, minor, measured power, major, minor, measured power. So So this is where we actually start looking at the specification. We're doing cryptography way later. So we need a 16-bit service UUID and a 16-bit service data. Contact detection service by way of its 16-bit service UUID. The service type, the service data type with this service UUID shall contain a 128-bit rolling proximity identifier that changes periodically. Okay. So length 02, length 03, length 13, type 16, service data 16-bit, service data. I was thinking this was the entire packet, but I'm not. Are these the same? Service data FD6F, FD6F. So this is the service 16-bit service UUID, and this is the service data. Okay. Service data. But I think the length is indeed this 128-bit. OX13 is what? Hey, quit that. I mean, the total length is going to be, according to this, the total length is by way of its 16-bit service UUID. The service data type with the service data UUID shall contain. So the 128 bits is going to be divided by 8. I can do this math, but it's easier to not do it. So right, 16 bits, and then the 16 bits in front of it for the service UUID. And then a flag. Is this flag also a bit or another length on top of this? 3 sections. Flags. LE discoverability mode bit shall be set to 1. The complete 16-bit service UUID section shall precede the service data section and the service data section. Okay, so hopefully this should fit into this somehow. Primary service. So this is the more complicated, like, actual services. This isn't really a service. This is a dumber entity than a service. But I think I'm thinking this might actually be, the UUID might just be a rolling identifier. It's not an iBeacon though, so I need to not look at the iBeacon, because that's not what this is. I think though that it is indeed just an advertisement. Service UUIDs. 1, 2, 3, 4, 5, 6, 7. Oh my goodness. How long is this? Okay, so if this is 1 and this is 32 and these are 4 bits, these are not 4 bits. Yeah, they are 4-bit octals. Yeah. 128. So yeah, here's our 128-bit random service UUID. But this is still missing a... Still doesn't seem right. Name maximum. Yeah. Let's go look at examples and see if we have any, like, real... See, properties are too complicated. There's no property to read or write here. This is just a low energy advertisement. Characteristics, no, it's not characteristics. It's not even a service. This is like simpler than everything that is here so far. Still gonna be a service. I mean, I could be mistaken about my understanding here, but like... So there's this name of... Still trying to figure out whether start advertising is actually going to give me the sort of... allow me to broadcast this particular... Well, it does say a service registered with the UUID. We're scan for contact detection service. Service data type. The service. Okay, so there may actually be more. I was really thinking this was just like a pure advertising beacon that didn't need any kind of service associated with it. Advertisements are to be connected directly by way of an advanced non-connecting end. Yes, this is just advertisement. Okay, so EIR data, advertisement data, scan data. Undashed service UUIDs. Okay, so this really does look like I just need to munch these three different pieces together. Um, it is a little bit of a question of scan result should be timestamped with RSI captured. I mean, I can look back at service more, but I don't think there was much in service per se that had. I mean, services have characteristics, but I don't think this is about characteristics. It could be a characteristic, maybe. Was it talking about notify? Was notify? Yeah, because it's like. On notify sent handler. Ind. There's that ind. Advertisement, non-connected ind. I still think I'm making this overcomplicated. I still think that there's really a. I mean, first we need to state change it to make it. Bleno wants me to state change it, but I think the real. Yeah, see, this sounds more. That's a long, extended response. I mean, hopefully this shouldn't even need extended response. What is. Is this really just advertising? This is really just advertising the name and service UIDs. But I'm not trying to advertise a name. Are there any examples here? Blink1 UUID. I mean, the name could be the like 128-bit name. So that might be the name, maybe. I mean, I'm guessing here, right? So there's a flag. I mean, is the flag even a part of the 16-bit service ID? Payload has 3 sections: a flag section, a 16-bit service UUID, and then the service data. 16-bit UUID section shall be a 100. Why are you telling me service data is a 16-bit UUID? Complete 16-bit service UUID section shall precede the service data section. So there's a service, and then there's service data, and the service data kind of has its own UUID. That's kind of what I feel like, but I'm definitely shaky on that. Type, flag, type, complete 16-bit service UUID, type, service data, another 16-bit UUID. So there's 2 of these 16-bit UUIDs for a service UUID and a complete 16-bit service UUID and service data 16-bit. I'm sorry, I really thought that this was going to be, I thought the advertisement was going to be a relatively simple step and require very little understanding here. I can try and start throwing stuff at it, but my ability to feel like there's any confidence for any of this going right is going to be pretty shaky. But let's at least throw a little bit of code at this. Something about state. I'm going to break this up a little bit. it's just not a valid hex code. Okay, let's start simpler. One, two, three, 4, 5, 6. And 6 and 10, but these are octets. Oh, but they're, yeah, so they each represent 8 bits. True. Okay, so, so 8 bits times 16 is only 64, so, but that's, so I'm still trying to handle this like a number, but I think I've already gone past, I've definitely gone past what max safe int is, so we're going to need buffers. They're just in string land. Callback, what state? Boy. Please behave. I think it's that powered on is what I was looking for. State must be powered on. Okay, so now we have a little program which should start Bleno. Bleno should start up. It should go into power on mode. It should issue a state change event, I believe, at some point. And one of those state change events should be powered on. Is that right? Powered on. And then when that happens, we can start to advertise, and we will flip our is running bit, and we will advertise. So advertise is this guy. We're going to need Bleno again. I'm not sure if this is really the right. Let's see what actually happens when we REPL import Bleno. That's unfortunate. So it wants something, but it's not finding. Abandonware, Bluetooth HDI socket. Modules, Bleno node. So slapping that into place crudely, we should be able to open node, get Bleno, and see from there. Cool. B.default. Bleno. So I'm a little curious what the Apple version does. So these are for iBeacons, but iBeacons have a UID, a major, a minor, a measured power. I'm expecting binding start advertising. Ugh, drat. Okay, so it too is just going to call some underlying library tool. I was hoping it would give us a little bit more clarity on what was going to get called. Service UUIDs. So they're really just removing dashes from service UUIDs. And then they're passing it to whatever is underneath with this name and then the service UIDs. So I continue to want to believe that the service data really represents the name, but let's just go look for comparison to see if we can find some other languages ideas for what they are doing with Bluetooth, to see if that just looks, if this Bleno library just looks totally different. Find the devices, connect the devices, discover characteristics, find the characteristics we want, do things. So this isn't advertising. Socket interface. Not seeing any references to docs or API docs. So I'm just looking at the raw BlueES Linux kernel interface system source. There's a docs directory, advertising API. So I could do this over Bluetooth directly. String with type broadcast. These are properties of a advertisement in 16 or 30 movies. So this is a dictionary of UUIDs to the associated data. So that's really, that sounds good. That really sounds right. The service data's identifier to its value. That's what that sounds, that feels right. Now I'm back in Bleno. There's this bindings that are still mysterious. So it's not doing anything other than calling the generic application profile. So maybe that's part of the, is that too much? Is that like more than? No, good. Name, service UUID. Okay, so service UUID is 16 bits, service UUID is 128 bits. So 16-bit service UUIDs, service data, 16-bit service UUIDs. Okay, turning on this debug is going to be clutch whenever I get there. And there's a stringification of service UUIDs. So they're expecting hex input, and they're down converting some hex input into some buffer data to get a service UUID. If length is 2, if length is 16. Some flags, right? uint 8. write 8 bits, value to look offset, write 2. Oh no, so the flag isn't even right. This is like hard-coded type flags, length flags. Bit 1. Okay, bit 1 shall be set to 1. Okay, validated. The very first byte is correct in our advertisement data. We're looking at the Bleno source, we're looking at its HCI socket, looking at this GAP. I forget exactly how this Bluetooth stuff, I forget a lot of how this Bluetooth stuff works. So for the very first byte, 0 offset, we are writing a 2. Great. And then the next byte, we're writing a 1. And the byte after, we're writing a 6. Why? It says length 2. Are those... flags. Flag section. So how does this, what does this have to do with these flags? I apologize. I thought this was more straightforward. A 2-byte header and a variable payload. The actual length of the payload is defined by a 6-bit length field in the header of the advertising channel PDU. Several types. Non-con int, yes. Does not want to accept connections, which is typical in beacons. So this is starting with the same, this is the iBeacon, and it is starting with the same pattern of the flag of the broadcast bit, and then a 1, and then a 1, then a 6. A 1, then a 6. So I would not be told, aha. Advertisement. Sweet. AD type, specifies what data is included in the element. AD type 1 or more bytes, meaning the defined by the AD type, AD data. Okay. Flag, then OX1, and then OX6. Yeah, it would be great to be able to type some data into Wirecast, Wireshark, and see what the results are. Type OX1 equal flags, broadcast value, OX6. O2, O1. So this looks like what we have. Like, this is correct so far. And then it's up to us to start. List of 16-bit services, value, whatever value. So this is the OX3 that we're next looking for, that we're going to have to generate. Here's our OX3. Sweet, okay. So this is length 2. It's a little odd, because it's only really the 1. So what's this other part of this flag doing here? I mean, I don't think it's right. I don't understand what it's trying to represent, but so this is type OX3, a complete service. Type OX1 flag, type OX3, right? We were seeing the OX3, right? Type OX3, complete list of service values, value equals 1809, 1809. Okay, so it's packed crosswise, but here's a service UID. So we just need to include our service UID, which is going to be, but that's already, we've already gone too far. Okay. OX1 flags value, type 1. Okay, so OX2 just means advertising, and then this is actually lining up. This is actually making sense. So we've gotten I'm sorry for the flipping back and forth. We've written a 2, we've written a 1, we've written a 6. So we've written a 2, we've written a 1, we've written a 6. And then it's really up to, I think the next is really up to us for whatever our 16-bit. So we have a 16-bit service UUID, but then there's going to be like the payload. Is it just really... So it's starting to push data into one of 2. So it's really reading, it's really expecting 16 bits. Okay. And here is really length AD type, type OX9, advertisement type OX9. So this is only a complete local name. So I like this, but why is this only 16? This is shorter than, how do we have this like 32-bit service data? Oh, type 16, and then the service data is going to be, but this is like bigger than I'm expecting. And then there's 16 bytes of rolling proximity data. What about the rest of the... $128-bit. Sorry, I'm still... My math is still... Yes, that's 16 bytes, right? So this resource is actually helping me out a bit. This one looks similar. Value. So this is multiple values packed in. So where does this name get used? Cool, so name doesn't get used unless I put it, where does scan data, advertisement data, scan data? Do we see scan data happen? Name and name length, scan data, plus name.length. Scan data, new buffer, scan data length. 0, 0, 0. Okay, so if name is empty, nothing's going to happen with name. Okay, so I can clear out name. So there's like two things I need to be doing. I need, like, it's kind of just like I have to start with, I mean, I think this really could just be that I just need to and then have my like 32-bit, my 16-bit data down on the backside. Let's go to rolling ID. I'm tempted to, yeah. So random gives me a, let's really go to crypto. I'm in part doing this just because I don't even trust myself to make a 16-bit fake random number. Okay, so we're making 16 bits of random buffer noise. Cool. Is this going to freak out at me if I give it? It's totally going to freak out at me if I give it something other than, if I give it useful data. Well, it takes length. New buffer. Service IDs. What does that even? Okay, so now we have an id.length, which looks good. Let's try and figure out what happens if I pick out something random from it. So we're just going to try and run this. So I'm pretty sure this is all going to break down. And then I need to convert these random IDs out to hex to make this thing reverse work with it. So we're trying to work with this rolling ID. What are they calling it? Hopefully now we have an ID, which is hex. Good, great. And now if we have a new ID, we should have a new random rolling ID. These are, again, fake rolling IDs for now. Do some of the cryptography part later. So we are going to... So they have this weird... new buffer. Service UUID is the service UUIDs matching up to 2 characters. So they're kind of like splitting the whole thing into 2 character things, and then they are reversing the 2 characters backwards and then rejoining them. And that's just for like a byte ordering thing. But they're still leaving everything in hex, a new buffer out of hex. And then they're going to push it into this array. This is a little convoluted, this library, but and so it should be service UUID.length. Oh, so there's multiple. So we're going through each of these service UUIDs as an array, and each element is a service UUID. Okay. So it's got to include, I mean, there's no other place other than, this has to be the, where else does this, so this needs to change, because this is something that is actually going to be changing over time. It's not a constant value. So we're just going to make this a function that does the thing. So again, this is just a fake thing that it's doing for now. At some point we'll start doing the cryptography side of this thing, but its ultimate job is just to produce a random 16-bit number that yeah, I can leave it at that. So we're producing a random 16-bit number using Node's API. And then we're converting it to hex to make this advertisement library happy about it, Bleno. So now we have this rolling ID, and we need to, when we look for a rolling ID, ask for it. And let's go take a peek. Is there any way that I think I actually need this argument to be set up. I don't think promisify gives me that. Okay. You hate to see it, but we're going to write it. Maybe let's just this is still, so this still doesn't, if length is 16, but length isn't 16, this length is buffer, there's this is 16, but this is another 2 on top of it. So let's try calling this bad boy. Shed. Let's call this bad boy. And this. Yeah, so that's just doing the piecemeal, reverse ordering the hex pairs. So it's not changing the length. And then the whole thing is though just yeah. Whew. Not good. So this is too long. This is too long. So this is going back to this guy. These guys are all writing flag stuff, this flag stuff. And then after that, advertisement data. It is going to be a 16-bit service UUID, almost certainly. So we're going to write 1 byte with a length. 1 plus 16 times length, advertisement data offset. Which so far has been, so we're at the next byte after these bytes have gotten written. We're at the 4th byte. We're going to write the length into this byte, and then we're going to write 06 into advertisement into this next byte. Where's this 06 coming from? That's a different type. Length, type, flags, length. We've never written a length before, have we? No, we have. Is that what that really is signifying? But that's, the flags though still don't make sense, because this is still 1xa. Discoverable mode bit shall be set to 1. Shall precede the service data. Service data UUID section shall prefer the service data section. Maybe this really does, maybe this isn't an advertisement. Maybe this really is more complex than an advertisement. I feel like I may have, because there's just no room for the service data. There's no room for either of these. Like, all that we're advertising is a service UUID, according to this 16-bit service UUID. So I can look at services. We can go find services here. So here's a notify, which is 1. A 1, like, that kind of corresponds with what type is this? Type 1. What else? What is A? A is 8 is a read. Okay, so this would kind of like trying to vaguely map properties onto a flag of 1A, but that doesn't seem to make sense. Like, maybe this is a notify property, and maybe it, but it doesn't seem like it would have a write property, but it does seem like it would have a read property, but I don't think that's correct. That seems incorrect to... I don't think there's going to be anything in here. So I'm way in the HCI socket directory. Remove dashes, primary service. UID has characteristics. Let's look at this. Let's look at the primary UUID. Does it have any? Just remove dashes, options.uuid. Here's primary service. It has a characteristic. So characteristic has a UUID, yes. Has properties, secure, and value. Okay, maybe. notify, no indicate. But on read, what? More UUIDs. Let's see what else. This is the cryptography specification. I don't think this is going to show us any. This is just about generating the keys. Could really use a little bit better starting help. Blog.google. Right, okay. That's the type. PDU type, and then the PDU header. I think this library might just be a little short on what it's trying to give me. Sorry for this, that can go away. Service, characteristic. This is still advertising, but I think this advertising has like a specific kind of advertising that it's doing. Set service, bindings, set service, on service set, emit set service. Yes, this is just calling through to bindings, which it's calling GAT set service. What else is in here for services? So get is doing the work of what services do. Let's take a quick look at these. MT request, finders request. I think these are underlying communication tools that this library is using to talk to HCI socket, which is the underlying protocol that I think the kernel is setting up to talk about the Bluetooth device. Success invalid. MTU 23. So set service. Is it really going to have a device name all the time? Because this is really supposed to be... I like this. The UUID for these characteristics looks like the right length. All services, UUID. Okay, so... read, indicate. Service changed, I think, is what's... I think... Let's see if this makes sense. Appearance, gap, appearance, read. Device name. Okay, so these are the gap. These are the specific characteristics names. So that's good. So I think then we need to not have all services if we can not have all services. Oof. Okay, so it always wants to have all services, so we might have to go hack at this code a little bit, but or risk being a little less secure. But I think this is the right path. We are trying to... let's copy a service out. Okay. This is a time to check in now that we've made a bunch of not quite right things. We're still going to need hex. We're still going to need hex. So this isn't really advertised that we're trying to do. This is really like start service. So for a service, let's just start by So I'm still looking at GAT to try and understand a little bit better what exactly it does. Okay, so this set properties read. There's no type 03 length complete 16-bit service UUID. So this is 16 bits. 4 bits, 4 bits, 4 bits, 4 bits, 16 bits. But length 3, because it's still the type is complete 16-bit service UUID class. Right. Right. So that's the service UUID. Yes. I feel like we're going to need Bleno here shortly, but jumping the gun a little bit. I think this is going to require a little bit more footsing. I think this is going to require some significant rework to make this happy. So we have the value, which is going to be our hex, must be of type buffer. Okay. So we're going back to rolling ID, and now we have a buffer back. The characteristics UUID is the service data UUID. And these happen to be the same, but I feel way better, even though they have the same value, calling them out differently. FD6F, 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 FD6F. Cool. Okay. The service UID is so totally boring. There's nothing exciting about it. It's literally a length of the length byte plus. Oh. I guess length does include the length itself. So it's the type byte, and then these 2 bytes. Is type really 1 byte? Type's not 1 byte, because look, here we have a 2 byte type. Maybe type is like automatically included, but then why is the length 3 unless it's 0, 1, 2, 3, I guess I need to trust that that is going to be okay for now. Properties. Now here's the real question. What are these properties supposed to be? Result, callback result, result success. Specify read request handler via constructor options or by extending characteristic and overriding on read request. Offset and callback. So what does the chart really show? It doesn't show any. So this is the advertisement flow. It's generating the keys, it's deriving a proximity key with the local provider, it's getting the rolling proximity identifier, and then it's just advertising it. There's no save rolling proximity identifier, 15 minutes elapsed, advertisement, contact service UUID, rolling proximity identifier. So there's no. There's still no. Service data, 16-bit UUID. Diving back into GAD. Someplace there's going to be building big, huge buffers. Service characteristics length. For each characteristic, properties, index of read, add write without response. And I'm not really sure which. Presumably read means somebody can read my property, read this characteristic as a property, and write without response means write into this without a response. Write means write with a response to it. Are these type? So this type though, is there an OX16 in the house? There's not. Attribute OP prep write request. That's definitely not what's going on there. I don't think this is for us. This is some definite Linux funkitude. Reset buffer, set socket filter, init device, set event mask, reset. Read LE supported, read local versions, set LE event mask, set advertising parameters, header, advertising parameters. This actually looks surprisingly real. I don't know what these are. Advertising parameters, advertising data. Ooh. So header. Wow. So this is writing some sort of packet to tell Linux, hey, I've got a HCI command. We're going to set advertising data. Here's going to be a length of it. We're going to write 32 at this spot. Then we're going to write this data, which, like, that's really what we're doing. This is really all getting packed into 16 bytes plus a bunch of other stuff. But I do think this service is I think we're on the right area with this service. So this is unfortunate that set services wants to, how much other stuff is it doing? Setting handles. What do these handles get used for? Handle plus plus, characteristic handle value is handle. Type characteristic UUID, type characteristic value, handle characteristic value. So it's kind of like splitting this into the composite pieces, which I kind of get, because it really is, there's the two pieces. The UUID, the properties. Thankfully, I haven't seen this. Okay, so noticate or indicate. So I was nervous about this thing. Let's do some quick, oops. So I kind of think this type might happen automatically, this type 16, but I am still, both of these types, I'm very curious to know what they really are, how much they are a result of the things, the like properties set on them versus advanced scan request, scan. Definitely been at the random searching phase for a while here, haven't we? That's extremely hard to read. Yeah, see, that's what we were just looking at, TX and RX address. And here's that flag 2, that how do we get our flag 2? That's really the service's responsibility. Characteristic description, we're not doing any descriptions. Debug handles, I don't even know. I don't think, I mean, I'm hoping ACL is literally something we don't have to worry about. Oh no. Send data to string, hex, send data. I mean, hopefully we're not sending. E. Handle read by transport type. Request. So it seems weird to me. There's nothing about, it's an advertisement. There's not supposed to be any request. time check. I've been at this for 2 hours, so I haven't been making nearly as much headway as expected. Yeah, I still want this advertising thing to actually work because it seems like it seems like it has some of the right elements to it because this looks right. That's the right advertisement data. We want to write that's like the advertisement flag, and then we're writing after the advertisement flag we really are writing 1.6 next. But I don't think that's not correct though. This packet should also be including a service UUID. So is there a service UUID and then there's no payload here though, is the confusing part. Unless the service UUID is the short bit, then the name is what the payload is at the end. Scan data. So we're writing the length, and then we're writing... No, that is not what we were trying to write. We were not trying to write an OX8. Nothing is trying to write an OX8. Yeah, this is trying to write an OX16 service data. So this is the Android docs. This looks like the sort of add service data. We can build an advertise data, attach service data to it, add a service UUID to it. Oh man. Okay, so where's this scan? Okay. There, if I try starting, yada yada. Set scan response data, scan data. now. So it really comes down to set advertising data. That's really all that's happening, isn't it? Everything's really this HCI. Set advertising enabled, set advertising data. So how much of this do we want to copy? How much of this really makes sense? So the advertisement data should include the type. What are we including next? A flag, OX1. And then what is it doing next? Flags. Does that, no, so it's 1, 2, 1. 2, 1, and then flags. That sounds good. This is the types. So type 03, complete list of 16-bit service class UUID. Yup. Type 16, type 6, so sorry, type 3, and then type 16, or type 16 is service data. Okay, that all sounds great. What is this? Is this a type? This is not a type. We've already sent the type. The type was the flag. The type is flags OX1. It's this. This is the flag. So length to flag, type flag, flags incorrect. Okay. Okay. Let's just do the real thing. We're going to start advertising with this longer one, and it. There's not even a callback for it. Mercy be. Is there no callback for this? There's no callback for that either. Cool. Okay. So we have 16. We want a rolling ID. And this is going to have to change some, like, the rolling ID does need to be rolling over time, but we can kind of worry about that by changing this piece of code independently up here. What we've got to do now is we've got to write this data packet, and I think we're going to know the ultimate length, so let's look at what the constructor for buffer looks like. How do we make one of these? Yeah. So length is a byte, type is 2 byte, a byte. That can't be a byte because this keeps going. Yeah. Okay, so there's 2 bytes. Is there some interesting encoding here? Goes up to 3D. First is length. Figure this out as we go. I should not be writing uins. I should be writing, that might be part of the difference here. Uint 8, okay. So I think I don't have access to the Bluetooth. Oh, maybe I do actually have. Maybe. Come on. Let's go read some flags, everyone. This night just got exciting. Yeah. Flags. Give me flags. Maybe need to go back to that index. So just AD structure 1, AD structure 2, AD structure n, non-significant part. AD structure 1 octet, length octets, with data of AD type, and then the AD data. If length is set to 0, then data has 0 octets. That sounds reasonable. The first octet of the data field contains the AD field type. Yes, the content of the remaining length minus 1 octets. Cool, so length is of the everything other than length. But type is still... So how is length supposed to include type plus the flags of... This flag still seems just simply incorrect. Like... Except there were a lot of flags when we were looking at this. This wasn't the, this was the assigned numbers. It was actually telling me where I needed to look. Let's go look at that. Section 2315, 2313. Boy, this is 5.2 core specification, 5.2 core specification, 2.3.1.3, 2.3.1. Bluetooth core specification. That is not. There's of course no contact info at all on any of this. Information copyright, subject to yada yada. That figures. Back mode, optional ACL services without connection. I mean, remote name inquiry, periodic inquiry. Link manager protocol. Nope, thankfully not. General audio recommendations, audio. Did they really send me to... They really sent me to something that doesn't exist. They would. Might actually be something in this. It's totally not. Physical channels, physical links, logical transports. Logical links. I still don't even think there's like a link. Packets. Bit ordering access code. Packet headers. Yeah. Packet types. Common packet types. What does this say for flags? Common specification volume 3 part C. Volume 3 part version 4.0. Bluetooth core specification. Volume 3 part C. flags. Yeah. Let's go back to the top. Is there a 2, 3, 1, 3 that makes any sense here? 2, no. But we got flags. We can check out flags. Flag data. It's a bit. It's a byte. Oh, so good. Discoverable mode. Bit 1. Yes. Oh, thank heavens. Okay. Hey, sorry about that. I don't know what happened. Everything was going fine, and OBS was saying it was streaming, but streaming it was not. Anyhow, I'm actually making a little bit of progress right now. I'm not really sure where we left off. I was super excited to find super excited to find the Bluetooth specification, which I actually didn't think was public, but the main thing I found is flags, and flags gave me the feel goods. I'm still a little confused why their flags is 0, 1A, but according to this, I mean, it would have to be some weird unspecified bit settings to be 0, 1A. So I like what they are telling me in their specification where it says flag section. LE general discoverable mode bit 1 shall be set to 1. That makes a lot of sense, and I can do that. And that's in the specification. So what we've got is we've got the flags. The first thing, so the Bluetooth advertisement packets are broken into a series of segments. Each segment starts with the length, saying how long the remaining octets are going to be. In this case, there's 2 more. There's a type. The type is type 01 flags, and we can go to this big old chart of assigned numbers and gap, which tells us what the types are, and type 1 is flags. So that's actually... So I'm suspicious of that, actually, because that type is more than a... That type is... Why would that type... Why would that be... I mean, I've seen this example before in this way, but it still confuses me. I'm sorry, I have a whole bunch of just random results up here, but here we are, like type 01, type, okay, so length 2, type 01, each, so that's a 8-bit? Oh, okay, that's 8 bits. Right. Okay. And then the value is this LE general discoverable mode, which is in the specification. So that all seems reasonable. Int 8, 8-bit, 4-bit, 4-bit, 8-bit. Okay, sorry, I'm just trying to make sure everything lines up. Everything's going a little slow in my head at this point. But so for the service UUID, we're going to have a length, and now we can really look at this this specification packet, and actually things kind of makes sense. Length 3, so type is, yeah, so and I'm missing that. So the type is 3, which is go look up what 3 is, although I've just seen it before. So this is a service class UUID, which complete 16-bit service UUID. Things are making sense. So, and I think I need to flip these around, or like, is this, I mean, I can do it and see what happens and hopefully snoop it later. Three, 4. So is that gonna write? Is that gonna write? So here's the other thing I think I kind of want to do now. Is have the preamble be I guess I'm just gonna do something terrible, which is pad the latter. What do I want to do about this not being regular sized, about this being? Because these are like UN8, but then suddenly we've got like this UN16, so like how am I knowing how I'm gonna pack this? I don't really know, is the thing. So I liked this idea of having I mean, I can keep going. And just make sure everything is a UN8. Sweet. So this one's one longer, and then, so is this right? Or is this backwards? Higher bits ladder, I think it's, let's, all numerical multi-byte entities and values are associated with the following data types shall use little endian byte order. So I'm pretty sure I got this backwards. Yeah, I'm pretty sure this is backwards. Ugh, I do not like your nomenclature. The most significant, so big endian, the least significant byte is at the lowest address. Okay. Let's just make a helper for that. Okay, so what we're actually trying to do is we're trying to return a series of 8-bit value, 8-bit 8-bit values. I have number, and so we can hello. So what we can do, number will normally hopefully tell us how many bytes it has, but if it doesn't, we'll be able to tell it. And to do that, we just want what do I need to do? Like a log. I need like a math log 2 of the number, I think. So this still fails with. Okay. No, actually, 0 is the only. No. Yeah. Passing in 1 is still getting back at 0, but like. I'm fine with this. Okay, so little endian, so we want to keep pulling off the lowest. So that lowers it, but how do I actually, I need to like mask and then shift. So starting with the full number, I want to, what was I going to do? I need to mask the lowest and keep rotating it down. Cool. And yeah. So now cool. So now we're sending two things. We're sending a flag that says this is an LE general discoverable mode packet, and we're sending a 16-bit service UUID in this preamble. The next thing we need to do is start to set and build the packet for the actual service data, which is where most of the data is going to be. But we still need two things to start us off. Specification for this contact tracing. So length, that sounds right. Type. Let's go verify our type. Is that really? This is the supplemental. This is main spec. I wanted to look at went off course. Hey, it's service UUID. Let's go to the main table of contents. Hey, the main table of nope, still not the main table of contents. Why does it start at page 89? Is that how big the table of contents is? Oh my goodness, that's how big the table of contents is. Wow. Page 85. Okay. I was looking for, I wanted to make sure that I understood this type for this service data. Flags, service UUID, service data, yes, format. Okay. Length 13, type 16. If you want to look at this. There's a bunch of different parts. I haven't figured out how these different parts work and play together. Volume 3A. Part G. Part C. But this is still volume what? Volume, oh, this is volume 0 because I haven't made it anywhere yet. Part C. Part C. Okay, Part C. Sections. Volume 3, Part C, sections 11, 110. There is no sections 11. Is there anything in Part C here that looks interesting? Link manager stuff? No, this does not look interesting. This looks very uninteresting, thankfully. Okay, so I was hoping to get a little bit more. I was hoping to see exactly. So there's a couple different formats, but this isn't actually giving the index for like what the values are, which is fine. Like, this is accurate. But then we have our service data, which is again, ooh, I'm missing a dot. But that, I guess that's what I was trying to look at. Like, I only know that because the length is long enough that there's 2 more bytes that have to fit in here. But okay, that's fine. So this is the preamble that is going to start everything else off. And so from there, so how do I turn a bunch of bytes into buffers? Okay, so it's actually doing buffer from will just give me what I want, which is nice. But I'm trying to mix, which isn't good. Hey, behave. Okay. That works. Okay, so what we've done is just manually recreated rather than trying to use Bleno, a packet that just has the flags on it, it has the service UUID, and it has the contact tracing data, service data available to it. And it has this rolling proximity at the end of it. So now to send this out, I think all we have to call is start advertising data with thing. There's not even a callback for this. This is just a thing. Yes, if error. This dot emit advertising start error. Eek. Gross. And there doesn't seem to be any positive indicator, although there might be. Okay, so it'll tell us some random stuff in events, but I don't know if the scan data is, but I'm hoping it is ignorable for now. But we have our advertising data. Start advertising with EIR data. So this should give us an advertisement for this data. And I think we're pretty close to, I'm just going to delete this. here, a little fix there. Cannot create property 1 on number 0. Oh. I don't know, what do I have to scan with? I was planning on running the web app real quick, but this one took a while, so I don't think I can really. I don't think I have anything that just like magically scans on Bluetooth on my Android phone. I wonder if I can wirecap. I really don't know if this is going to work, but especially like, do I need to be root right now? I might need to be root. Ooh, DisplayPort aux channel monitor. That sounds fun. I need to look at that someday. Systemd journal export. I mean, I don't think I have any way to. I was hoping I might get like some kind of loop back mode. Just trying to figure out how to. I still don't think this is going to give me anything, but I'm trying to start Wireshark with sudo privileges so I can display name, protocol, hex key. And we have a couple more interfaces now. We can actually have multiple Bluetooth interfaces on this box, so I don't really know who's trying to advertise this right now. I don't know if anything's actually even successfully advertising. But this is still running. What have I called? Give it a second to settle, just in case. So state has never changed. So I think I still need to do something with sorry, I think I still need to do something with Bleno here to make it go. I didn't see anything else that seemed before advertising started. None of this is correct, or is state change state. How do I? So I still don't think this is. I'm still skeptical if things are going to be better now. Sweet! Would you look at that? Powered on. It crashed. So ID is a promise. That makes sense. And this buffer misuse is not my fault. Command complete. LE, set advertising parameters. Opcode, set advertising parameters. Group field, command field. What's all this mean? Can you show me this in hex, please? Blah, 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 blah. How do I make you as hex as bits? So these are advertising parameters, advertising enabled. I mean, I'm actually kind of expecting this to be like scrolling by. We're supposed to be advertising like a lot right now. We are advertising a lot. Not consistently. Set event mask, LE set event mask. I mean, there's like background traffic happening on this device, almost certainly. Read DB. Right, LE host supported. So just to clear, let's just do this again. So yeah, we got a ton of stuff showing up right away. Read buffer size, LE command, advertising parameters. Channels, addresses, own addresses. I mean, these are really parameters. Connectable unidirectional. Connectable undirected advertising. I don't think it's supposed to be connectable. I'm still expecting to see like traffic going by. So this is the other, trying to capture on the other device. Buffer.from is not a function. That's not good. I'd seen some errors, but okay. So we need Set advertising data. Flags, 16-bit service class UIDs, service data UID. Boom! That's the proof. Sent LE advertising data. It's not doing it again. Do I need to keep doing this? I think I might need to keep doing this. Ugh. I think this is bad. Set advertising data. Well, I guess I'm not really expecting this Bluetooth capture because this is really capturing the HCI communication. So it's not communicating, it's not capturing what the card is really sending. It's capturing what's being discussed. So now I don't think I need to do this. I don't think we're going to see anything different, but let's try doing it again and seeing what happens. And I think we're going to see the same result of we'll see this advertising data set. That didn't go well. I mean, I was expecting more. Time 141. Time 147. Okay. Set advertising data. Set advertise enable. Set advertising data. Set advertising data. So these are a second away. Set advertising. And this is like instantaneously coming back again, the same. Oh, look at this. It's telling me all the flags. You're great. You're just super. Length, UUID unknown, FD6F. Got that right. LE is looking good. FD6F, type service data, here's the data. Okay. I mean, this looks good. I think this actually writes a random ID. Totally random so far, but I think we're able to get into a good spot where we can start to write a web application to start listening for these and recording them, and then reciprocally the other part is writing a actual cryptographic implementation to actually send out rolling IDs that have a parent keys to them, that have a daily key, that have a device or app ID. And once those are in place, we should have an implementation of the contact tracing specification here. That was pretty rough going. That was a little wild of a start, but and I wish I had a little bit better way right now to verify. I don't really have good tools to Bluetooth snoop and figure out what actually is getting sent out on the wire, but this Wireshark capture is making me pretty happy. This looks like it's setting the right advertisement data, getting a received command complete back from I don't really know what that means, but it seems like there's some confirmation going on backwards. So that's all really cool. I guess I could... I don't know what Bleno has for listening to. I don't think it has a listening. Yeah, I think it's mainly for making devices, and then reciprocally Noble is the one that is for listening. But I don't really want to play with those guys right now because I'd like something that works on the web. The web work's going to be a little bit interesting because I think I think I can do localhost development without having to worry about HTTPS, but I'm not really sure. I think I'm going to call it for the night, though. This took quite a lot of time and quite a lot of fuddling around before finally kind of finding enough sources of truth and evidence that showed me kind of like, okay, you're just going to have to, the library is not going to help you, but there's really only like a couple pretty simple pieces of bits that you've really got to write out. You're kind of manually writing 3 different packets. You're writing a flags mini packet, you're writing a 16-bit service UUID packet, then you're writing a service data packet, which also has another UUID in it, and then that last packet also includes, its length is considerably longer, and its length includes the ID that is going to be whatever the cryptographic ID that we're going to be generating is. And so with all of that, we can then start advertising to our device, and it should just start writing that packet out, which is cool. I'll come back tomorrow with a little bit more work on trying to actually get a web application going to listen to this. And so instead of having this computer sending it out, we'll have it sending it out and this computer listening. Hopefully it'll be a little bit faster tomorrow, but look forward to doing this work and hanging out with you later. Okay, bye-bye.